Now, in this lecture, we will answer on two questions. In the first question, we find out the blue area. In the second question, we find out the radius of this circle that blocks triangle ABC. So we'll start with the first question. In the drawing we have a big circle, and we know that AB is the radius of the big circle, and inside the big circle we have triangle ABC, and this small circle is inscribed by triangle ABC, and we want to find out the blue area. And we also know that the radius of the small circle is equal to 4 units, and the radius of the big circle is equal to 14 units, and we want to find out the blue area. Okay, first of all, we will define the center of the small circle as O. Then we will define the point of tendency B with the small circle as M. We will define the point of tendency of tangent AC with this small circle as N, and we define the point of tendency of tangent AB with this small circle as S. I repeat again, point O is the center of the small circle. We'll join points O and M together by a straight line. And we define the radius of the small circle as small r. We know that small r equals to 4 units. So here, point O is the center of the small circle, while point M is the point on the small circle itself. This is exactly the definition of a radius. That is to say, OM is the radius of the small circle that is equal to small r according to our definition, and small r equals to 4 units. So here we have the radius of the small circle that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent CB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent CB will be perpendicular to the radius MO. So here, CB is perpendicular to MO, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. So whenever we have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So if CB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. In the next step, we will join points O and L together by a straight line. So line segment OL Start from the center of the circle, from the center of the small circle, that is to say from point O, and ends at point L, that is the point of the circle itself. This is exactly the definition of a radius. So OL is the radius of the small circle that is equal to 4 units according to what is given as the question. So here we have the radius OL that is 1 to the point of tendency. That is to say it is 1 to point L, that is the point of tendency of tangent AC with this circle. And whenever we have a radius that is 1 to the point of tendency, then tangent AC will be perpendicular to the radius LO. So AC is perpendicular to LO, that is to say this angle equals to 90 degrees according to rule number 1, and this angle will be also equal to 90 degrees. Okay. And we know that AB is the diameter of the big circle. So angle ACB, this angle rests on the diameter of the circle. And we have the rule that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So here peripheral angle ACB rests on the diameter that is AB, therefore it must be equal to 90 degrees. So angle ACB equals to 90 degrees. Why? Because it rests on the diameter. Actually, we found out that for the other OLCM we have 1, 2, 3 right angles. Okay, right now in quadrilateral OLCM we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3, 270 degrees. That's the size of the fourth angle, that is actually this angle, angle LOM. In total, the sum of those 4 angles must be equal to 360 degrees according to rule number 1. Okay, 270 degrees plus the size of the fourth angle, this is actually angle LOM. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle, angle LOM, is equal to 360 degrees from 270 degrees, it is equal to 90 degrees. So I found out that the missing angle is a right angle, it is equal to 90 degrees. And this angle equals to 90 degrees. It is a right angle. So after we found out that in quadrilateral LOCM we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral LOCM as a rectangle. Quadrilateral LOCM is a rectangle. Why? Because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of a rectangle LOCM, they are equal to each other. What does it mean? It means that LO equals to Cm. NO equals to Cm according to the rule that the opposite sides of a triangle are equal to each other. We get that NO equals to Cm. Okay. But we already found out that NO equals to 4 units. It is the radius of the small circle. So we can write here that NO equals to 4 units. And from this equation, 4 equals to NO equals to 4 equals to NO equals to Cm. We will derive that Cm is also equals to 4 units. Yes, Cm equals to 4 units. So I can write down here that Cm equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, so rectangle NOCM will get that OM equals to LC. OM equals to LC. OM equals to LC. But OM equals to 4 units. This is the radius of the circle, the small circle. So I can write here that OM equals to 4 units. And from this equation, 4 equals to OM equals to LC. We will derive that LC is also equals to 4 units. LC equals to 4 units. So we can write here that LC equals to 4 units. Okay. In the next step, we will define side AC of triangle ABC as A. Here AC equals to A according to our definition. We will define side BC of triangle ABC as a B. Here CB equals to B according to our definition. And we define side AB, that is actually the diameter of the big circle, as C. So here AB, the diameter AB, equals to C. So here it is very easy to see from the drawing what is the length of side AL. From the drawing it is very easy to see that AL equals to AC minus LC. AL equals to AC minus LC. So AL equals to AC is equals to A according to our definition. And we already found out that LC equals to 4. So in conclusion, we found out that AL equals to A minus 4, AL equals to A minus 4. Likewise, it is very easy to see what is the length of line segment MB. From the drawing, it is very easy to see that MB, this line segment MB equals to CB minus CM. I repeat again that CB minus CM equals to MB. So MB equals to CB, that is equal to B units according to our definition, minus CB, that is equal to 4. So in conclusion, we found out that MB equals to B minus 4 units. So we can write here that MB equals to B minus 4 units. In the next step, I will present to you rule number 2 that I mentioned in the past. According to rule number 2, a tangent, the lengths of two tangents from a common external point to a circle are equal. I repeat again, the lengths of two tangents from a common external point to a circle are equal. So according to rule number 2, if we focus at point A is defined as common external point in relation to this small circle, because point A is not located inside the small circle nor on this circle, but it is located outside of the small circle. So from point A, we have two tangents to this small circle. The first tangent is tangent AL, and the second tangent is tangent AS. And according to rule number 2, the lengths of those two tangents must be equal to each other. That is to say, AL equals to AS according to rule number 2. Okay, AL equals to AS according to rule number 2. But we've already found out that AL equals to A minus 4. AL equals to A minus 4. So we can write here that AL equals to A minus 4, according to what we have already found out. And from this equation, A minus 4 equals to AL equals to AS, we derive that AS is also equals to A minus 4. Okay? AS is also equals to A minus 4. In the next step, we'll focus on the common external point B. So, from the common external point B, we have two tangents to the small circle. the first tangent is tangent BM, and the second tangent is tangent BS. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, BM equals to BS according to rule number 2. Okay? BM equals to BS according to rule number 2. But we have already found out that BM equals to B minus 4. So you can write here that BM equals to B minus 4. And from this equation, B minus 4 equals to BM equals to BS, we will derive that BS is also equals to B minus 4. Okay, BS also equals to B minus 4. You can write here that BS equals to B minus 4. So it is given us in the question that AB is the diameter of the big circle, and the diameter of any circle is twice as long as the radius. And we know that the radius of the big circle, we define it as capital R. Therefore, the diameter AB of the big circle will be equals to 2 times the radius, 2 times capital R. But it is given as the question that the radius of the big circle equals to 13 units. So therefore the diameter is 2 times the radius, that is to say it is 2 times 13. 2 times 13 is 26 units. So the diameter of the big circle equals to 26 units. Here we can write down that C equals to 26 units. On one side, the diameter of the big circle equals to 26 units. But from the other side, the diameter of the big circle AB equals to AS plus SB. So here, we know that AB equals to AS plus SB. Okay? That is to say, AB equals to AS is A minus 4 plus SB. SB is B minus 4. So we actually found out that the diameter AB equals to A minus 4 plus B minus 4, that is to say it is equal to A plus B. Minus 4 plus minus 4 is minus 8. Minus 8. So AB is the diameter, so it is equal to, we know that it is equal to 26. So in conclusion, we found out that according to equation number 1, the diameter that is equal to 26 units, it is equal to A plus B minus 8. Here we'll add 8 to this equation number 1, and we'll get that according to equation number 1, (26 plus 8 is 34) equals to A plus B. So according to equation number 1, we found out that A plus B equals to 34. Here we will square this equation number 1, and we get that according to equation number 1, A plus B square equals to 34 square. Repeat again. According to equation number 1, we found out that A plus B square equals to 34 square. We'll open the brackets on this side of equation number 1, and we get that A plus B square equals to A square plus B square plus 2 times AB and it is equal to 34 square. 34 square is 1156. Okay. So according to equation number 1, we found out that A square plus B square plus 2 times AB equals to 1156. In the next step, we will focus on triangle ABC. Triangle ABC is a right triangle because of the fact that angle ACB equals to 90 degrees. So we can implement Pythagoras theorem on the right triangle, triangle ABC. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AB. Therefore, the square of the hypotenuse is AB square. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AC square plus CB square. I repeat again. In the right triangle ABC, according to the Pythagoras theorem, AB square equals to AC square plus CB square. The diameter AB equals to 26 units, therefore AB is 26, and AB square will be equal to 26 square, that is 676. That is equal to AC square. AC equals to A according to our definition, therefore AC square will be equal to A square plus CB square. CB is B according to our definition, so CB square will be equal to B square. So actually we found out that according to equation number 2, (676) equals to A square plus B square. And because of the fact that A square plus B square equals to 676 according to equation number 2, it means that we can substitute A square plus B square in equation number 1 by 676 from equation number 2. we'll do it now and we'll get that here a squared plus b squared from equation number 1 is equal to 676 according to equation number 2 plus 2 times ab equals to 1156. So according to equation number 1, we found out that 676 plus 2 times AB equals to 1156. Here we'll subtract 676 from this equation, equation number 1, and we get that according to equation number 1, 2 times AB equals to 1156 minus 676 is 480. So we found out that according to equation number 1, 2 times AB equals to 480. Here we divide this equation number 1 by 2, and we get that A times B, according to equation number 1, A times B equals to 480 over 2 is 240. So we found out that A times B equals to 240. And what is the area of the blue shape? The area of the blue shape from the drawings is very easy to see that the area of the blue shape it is equal to the area of the triangle ABC minus the area of the small circle. I repeat again. The area of the blue shape equals to the area of triangle ABC minus the area of the small circle. It is very easy to see it from the drawing. So the area of the blue shape equals to the area of triangle ABC. Here the area of triangle ABC will be equal to the base of the triangle that is AC times the height to the base that is CB. The height CB must create 90 degrees with the base, and indeed CB creates 90 degrees with the base AC over 2. I repeat again. The area of triangle ABC equals to AC, that is the base, times CB, that is the height to the base, over 2. Minus the area of the small circle. We know that the area of the small circle equals to pi r squared, and r equals to 4 units. This is pi r squared. Okay. The area of the small circle equals to pi r squared, and r equals to 4 units. So the area of the blue shape will be equal to the area of triangle ABC, that is AC equals to A according to our definition, CB equals to B according to our definition, over 2. So the area of triangle ABC equals to A times B over 2. But we have already found out that according to equation number 1, A times B equals to 240 units. So here we divide equation number 1 by 2, and we get that according to equation number 1, A times B over 2 equals to 240 over 2, that is 120. So we found out that AB equals to 120 according to equation number A times B over 2 equals to 120 according to equation number 1. So here we can substitute A times B over 2 by 120. So here the area of the small circle is pi r squared, r equals to 4, therefore r squared is 4 squared, that is 16. So in conclusion, the area of the small circle is 16 pi. So actually we found out that the area of the blue shape equals to the area of triangle ABC, that is 120 square units, minus the area of the small circle, that is 16 pi. So the answer to the question that the area of the blue shape equals to 120, that is the area of the triangle ABC, minus 16 pi, that is the area of the small circle. So it is 120 minus 16 pi square units. Or in terms of numbers, it is equal to 69.73 square units. Okay, I repeat again. The area of the blue shape in the drawing, it is equal to either 120 degrees minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. Okay, so we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in 3 different methods. Okay, so in the second question, we have triangle ABC. This is triangle ABC that is described by this circle. We know that the area of this triangle ABC, equals to 9 square units. And we also know that side AB of triangle ABC equals to 5 units. Side BC of triangle ABC equals to 6 units. And we want to find out the area of this circle that blocks triangle ABC. So first of all, from point A, we will draw perpendicular on BC. I repeat again, from point A, we will draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point A and BC as D. Okay. So we know that the area of triangle ABC equals to 9 square units. The area of triangle ABC equals to 9 square units. But we also know that the area of any triangle equals to the base of the triangle times the height to the base over 2. In this triangle ABC, the base is BC, and the height to the base is AD. Why AD is the height to the base? Because of the fact that 9 segment AD creates 90 degrees with the base BC. So it is the base BC times the height to the base AD, is over 2. So the area of triangle ABC equals to BC times AD over 2. So here the area of triangle ABC that is equal to 9 square units according to what is given in the question equals to BC that is equal to 6 units according to what is given in the question times AD over 2. I repeat again, the area of triangle ABC that is equal to 9 square units equals to the base BC that is equal to 6 units times the height that is AD over 2. So here 9, according to equation number 1, 9 equals to 6 over 2 is 3. So 9 equals to 3 times AD. Here we will divide this equation number 1 by 3 and we will get that AD equals to 3 units. So we found out that AD equals to 3 units. You can write down here that AD equals to 3 units. In the next step we'll focus on triangle ABD. The right triangle, triangle ABD. On the right triangle, triangle ABD, by PT is the version for Pythagoras theorem. On this right triangle, we will get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AB squared must be equal to the sum of the squares of the perpendiculars. It must be equal to AD squared plus BD squared. I repeat again. In the right triangle, triangle ABD, according to the Pythagoras theorem, AB squared equals to AD squared plus BD squared. So here AB equals to 5, therefore AB squared is 5 squared, that is 25. That is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus BD squared. So in conclusion, we found out that 25 equals to 9 plus BD squared. Here we subtract 9 from this equation, equation number 2. And we get that according to equation number 2, 25 minus 9 is 16, equals to BD squared. BD squared equals to 16. Here we take out of this equation, equation number 2, and we will get that according to equation number 2, BD equals to the square root of 16, that is 4. So BD equals to 4 units. So we can write here that BD equals to 4 units. What is the length of DC? Here for the drawing it is very easy to see that DC equals to BC minus BD. I repeat again. DC equals to BC minus DB. So DC equals to BC. BC equals to 6 units according to what is given as the question. Minus BD. BD equals to 4 units we just write down found out that BD equals to 4 units. So in conclusion, I found out that DC equals to 6 minus 4, that is to say, this equals to 6 minus 4, that is 2. Okay, this equals to 2 units. You can write here that this equals to 2 units. Okay, so in the next step we'll focus on the right triangle, triangle ADC. On the right triangle, triangle ADC, my PT is information for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC square. And it must be equal to the sum of the square of the perpendiculars, that is to say it must be equal to AD square plus DC square. I repeat again. In the right triangle ADC, according to the Pythagoras theorem, AC square equals to AD square plus DC square. So AC square equals to AD square. Here AD equals to 3, so AD square will be equal to 3 squared, that is 9, plus DC square. DC equals to 2, so DC square will be equal to 2 squared, that is 4. So in conclusion, I found out that AC square equals to 9 plus 4, so AC square equals to 9 plus 4, that is 13. Here we take out of this equation and we get that AC equals to the square root of 13 units. AC equals to the square root of 13 units. So we can write here that AC equals to the square root of 13 units. Okay. In the next step we'll define the radius of the circle as O. Yeah, this is we'll define the radius of the center of this circle as O. Repeat again. The center of this circle is at this point O. We join points A and O together by a straight line. And then we will extend line segment AO by a straight line until it touches the circle. And we will define the touching point of the extended line segment AO and the circle as point E. Actually, chord AE passes through the center of the circle, and any chord that passes through the center of the circle is defined as the diameter. We can write here that AE is the diameter. AE is the diameter of the circle. So AE is the diameter of the circle, must be equal to 2 times the radius, so we'll define the radius of the circle as capital R. Therefore, we'll get that AE, the diameter, equals to 2 times capital R. But the diameter of any circle is twice as long as the radius, so A equals to 2R. In the next step, we will join points B and E together by a straight line. So we know that AE is the diameter of the circle. Here, angle ABE, this angle ABE, rests on the diameter of this circle, that is AE. And because of the fact that the peripheral angle ABE rests on the diameter of the circle, we have the rule that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. I repeat again that because of the fact that peripheral angle ABE rests on the diameter of this circle, that is AE, it must be equal to 90 degrees. So angle ABE equals to 90 degrees according to the rule that I mentioned, that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So this angle is a right angle, it is equal to 90 degrees. Okay, write it down. Angle ABE, it is a peripheral angle that rests on the diameter, therefore it is equal to 90 degrees. Okay. And we also have another rule that states that peripheral angles that rest on the same chord are equal to each other. I'll repeat again. Peripheral angles that rest on the same chord are equal to each other. Okay? In the next step, we'll focus on chord AB. On chord AB, we have those two angles, they are both rest on chord AB. Therefore, according to the rule that I mentioned, they must be equal to each other. That is to say, this angle ACB this angle ACB rests on chord AB, and here angle AEB rests also on the same chord called AB. Therefore, according to the rule that I mentioned, that peripheral angles that rest on the same chord are equal to each other, ACB equals to angle AB. So those two angles are equal to each other. That is to say, angle ACB equals to angle AEB. So here, if we define angle ACB as theta, here angle ACB equals to theta according to our definition, then from this equation theta equals to angle ACB equals to angle AEB, we will derive that angle AEB is also equals to theta. Angle AEB is also equals to theta. Angle AEB equals to theta. Here, triangle ABE is a right angle. We know that angle ABE equals to 90 degrees. Angle AEB equals to theta. Therefore, angle BAE must be equal to 90 degrees minus theta in order to complete the sum of the angles in triangle ABE 280 degrees. This angle must be equal to 90 degrees minus theta. Then you can see that 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees equals to 180 degrees. And from the same reason, because of the fact that triangle ADC is a right triangle, this angle equals to 90 degrees. This angle equals to theta. This angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in triangle ADC to 180 degrees. This angle must be equal to 90 degrees minus theta. So in the next step we will prove that the right main triangle, triangle ABE, is similar to the right main triangle, triangle ADC. Okay, we prove that the green right triangles, they are similar to each other. So I write it down. We prove that the right main triangle, triangle ABE, is similar to the right main triangle, triangle ADC. So why those two green right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So angle ABE is equal to angle ADC, and both angles are equal to 90 degrees, therefore they are equal to each other. I repeat again, angle ABE equals to angle ADC, and they are both equal to 90 degrees. In addition, those two angles are both equal to theta, therefore they are equal to each other. So angle AEB is equal to this angle, angle ACD, and they are both equal to theta. Repeat again, angle AB equals to angle ACD equals to theta. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle BAE equals to this angle, that is actually angle DAC, and they are both equal to 90 degrees minus theta, therefore they are equal to each other. I repeat again, angle BAE equals to angle DAC, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually prove that all three angles of triangle ABE can go into all three angles of triangle ADC. Therefore, we can conclude from it that triangle ABE is similar, this is the sign of similar, to triangle ADC according to angle similarity rule. Okay. The two main triangles are similar to each other according to angle similarity rule. And from the fact that those two main triangles are similar to each other, we conclude that AB over AD equals to AE over AC. I repeat again, from the fact that the two main triangles are similar to each other, we conclude that AB over AD equals to AE over AC. Here AB equals to 5 units. AD equals to 3 units. And it is equal to AE. AE equals to, it is the diameter of the circle, it is equal to 2R, 2 times capital R, over AC. AC equals to square root of 14 units. So in conclusion, we found out that according to equation number 3, 5 over 3 equals to 2R over square root of 14 units. Here we will multiply this equation by square root of 14 units. And we get that according to equation number 3, five times square root of 13 units over 3 equals to 2R. Here we divide this equation number 3 by 2, and we'll get that according to equation number 3, the radius of the circle that we are looking for equals to 5 times square root of 13 over 6 units. Repeat again, the radius of the circle that blocks triangle ABC is equal to either 5 times square root of 14 over 6 units, or in terms of numbers it is equal to 3.00 units. That is actually a little bit greater than 3 units. Okay. Repeat again, the radius of this circle that blocks triangle ABC equals to either 5 times square root of 13 over 6 units, or in terms of numbers it is equal to about 3.00 units. Okay, so I'm finished with the first method. In the next step, I will present to you how to find out the radius of this circle that blocks triangle ABC according to the second method. So in the second method we will use all the figures that we already found out in the first method. Here from point A we draw perpendicular on BC. We define this point as point D. We have already found out that AD equals to 3 units, DC equals to 2 units, and BD equals to 4 units. In the next step, we'll extend line segment AD by a straight line until it touches the circle. We will define the touching point of the extended line segment AD in the circle as point E. And we actually have a new rule that is actually rule number 1. According to rule number 1, this is rule number 1. So here it's called AB. This is called AB. Intersects with chord CD. This is called CD. At point O is the intersection point of chord AB with chord CD. Then, according to rule number 1, we get that AO times OB will be equal to CO times OD. I'll repeat again. If chord AB intersects with chord CD at point O, point O is the intersection point of chord AB with chord CD, and I must emphasize that the intersection point must be inside the circle, not outside the circle. So if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Okay, so actually we can implement rule number 1 in our drawing. Why? Because in our drawing we have chord AD, chord AE. This is chord AE that intersects with chord BC at point D. Point D is the intersection point of chord AE with chord BC. Therefore, according to rule number 1, we will get that BD times DC must be equal to AD times DE. So in our drawing, according to rule number 1, we get that BD times DC equals to AD times DE. BD equals to 4 units, DC equals to 2 units, AD equals to 3 units, and DE is the missing line segment. So in conclusion, we found out that 4 times 2 equals to 3 times DE. 4 times 2 is 8. 8 equals to 3 times DE. Here we'll divide this equation by 3 and we'll get that the missing 9 DE equals to 8 over 3 units. So if we know that DE equals to 8 over 3 units, you can write here that DE equals to 8 over 3 units. In the next step, I will present to you rule number 2. So this will be rule number 2. So we have a circle and we have inside this circle we have chord AB. This is chord AB that intersects with chord CD. This is chord CD. I repeat again, chord AB intersects with chord CD at 90 degrees. Okay? So the intersection point, at the intersection point, they create between them 90 degrees, angle of 90 degrees. Okay? We define the intersection point as point O. So, if two chords intersect with each other at 90 degrees, so here, if this is point A, this is point B, this is actually CO equals to A units in its length, OD equals to B units in its length, AO equals to C units in its length, and OB equals to D units in its length. Then according to rule number 2, we get that 4 times R squared equals to A squared plus B squared plus C squared plus D squared. Okay, 4 times R squared equals to A squared plus B squared plus C squared plus D squared. R is the radius of the circle that contains the two chords. Okay? Actually, we can implement rule number 2 in our drawing. Here, we did the construction, and from point A, we drew perpendicular on BC. So actually this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. Okay? And we also know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line AE at point D, then the sum of the angles here must be equal to 180 degrees. This angle equals to 90 degrees. So this angle must be also equal to 90 degrees in order to complete the sum of the angles on this side of the straight line AE to 180 degrees. It must be equal to 90 degrees. Okay? For that reason, this angle equals to 90 degrees. Likewise, from the same reason, if we focus on this side of the straight line AE, it's point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have on this side of the straight line AE at point D? We have here 90 degrees plus this angle. So angle AEDB that is equal to 90 degrees plus angle BDE, in total they must be equal to 180 degrees. So this angle must be also equal to 90 degrees in order to complete the sum of the angles at point D to 180 degrees. This angle must be also equal to 90 degrees. So we found out that all the angles around point D are right angles. For that reason, we can implement rule number 2 in our drawing. Okay? And according to rule number 2, we get that 4 times r squared, that is the radius of this circle squared, the radius that we are looking for, must be equal to BD squared plus DC squared plus AD squared plus DE squared. So this equation is the implementation of rule number 2 in our drawing. 4a squared equals to bd squared plus dc squared plus ad squared plus de squared. Okay? So here we get that 4 times r squared equals to bd squared. bd equals to 4, so bd squared is 4 squared, that is 16, plus dc squared. dc equals to 2, so dc squared is 2 squared, that is 4, plus the ad squared. ad squared is 3 squared, that is 9, plus de squared. de is 8 over 3, so d squared is 8 over 3 squared. 8 over 3 squared is 64 over 9. So in conclusion, we found out that according to rule number 2, 16 plus 4 plus 9 plus 64 over 9 equals to 4r squared. 16 plus 4 is 20, and 20 plus 9 is 29, so it's 29 plus 64 over 9. Here we'll multiply 29 by 9 and then we'll divide it by 9 in order to have a common factor with this expression. 29 times 9 is 261 plus 64 over 9. And 261 plus 64 is 325 over 9. So in conclusion, we found out that 4r squared equals to 325 over 9. Here we'll divide this equation by 4 and we get that r squared equals to 325 over 4, so 325 over 4 times 9. 4 times 9 is 36. 325, it is equal to 25 times 13. So we substitute 325 over 25 times 13 divided by 36. Here we take a root out of this equation and we find out that r, the radius of the circle that we are looking for, it is equal to square root of 25 is 5 over square root of 36 is 6 times square root of 13 units. So r equals to either 5 over 6 times square root of 13 units, or in terms of numbers it is equal to 3.00 units. It is actually a little bit greater than 3 units. So according to the first method, we found out that, to the second method, we found out that the radius of the circle that we are looking for, it is equal to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. It is 3.00, and then we have numbers that are not 0 but another numbers, another digits, so that is the reason that is a little bit greater than 3 units. So we finished with the second method. In the next step, I will present to you how to find out the radius of this circle that belongs to triangle ABC according to the third method. Okay. In the third method, we define angle ABC as theta. So we actually know that the area of triangle ABC equals to 9 square units. The area of triangle ABC equals to 9 square units. And we actually can calculate the area of triangle ABC in a different way. Here, actually, if we have a triangle ABC, that could be any triangle. This is triangle ABC. Angle between side AB and side AC is theta. The length of side AB is A units, and the length of side AC is B units. Then, according to the new formula, we'll get that the area of this triangle, triangle ABC, will be equal to A times B times sinus theta over 2. So we use this formula in order to find out, actually, in order to find out not the area of this triangle, but the value of sinus theta. Because we know that the area of this triangle is 9 square units, and the only missing variable here is sinus theta. So the area of this triangle, according to the new formula, here the area of triangle ABC equals to A times B times sinus theta over 2. According to this formula, we get that the area of this triangle, triangle ABC, is equal to, actually it is equal to AB times BC times sinus theta over 2. But AB is 5, BC is 6, sinus theta is the missing variable, over 2. So the area of our triangle, according to the new formula, equals to 5 times 6 times sinus theta over 2, and we know that it is equal to 9 units. 9 square units. So here, so 9 equals to 5 times 6 is 30, 30 over 2 is 15. So 15 sinus theta. 9 equals to 15 sinus theta. Here we divide this equation number 1 by 3. And we get that 15 over 3 is 5, so 5 times sinus theta equals to 9 over 3 is 3. So 5 times sinus theta equals to 3, according to equation number 1. We divide this equation by 3, by 5 of course. We divide this equation by 5, and we get that sinus theta, according to equation number 1, equals to 3/5. Sinus theta equals to 3/5. We found out the value of sinus theta. But we actually have also the trigonometric identity that states that cosine theta equals to the square root of 1 minus sinus squared theta. Okay. So cosine theta equals to the square root of 1 minus sinus squared theta. Sinus theta equals to 3/5. If sinus theta equals to 3/5, it means that sinus squared theta will be equal to 3/5 squared. 3/5 squared is 3 squared, that is 9, over 5 squared, that is 25. So in conclusion, we found out that cosine theta equals to the square root of 1 minus 9 over 25. So here, so cosine theta equals to the square root of, here we'll multiply 1 by 25 and then we'll divide it by 25 in order to have a common factor with this expression. So it is 25 minus 9 over 25. So cosine theta equals to 25 minus 9 is 16 over 25. So cosine theta equals to square root of 16 is 4, square root of 25 is 5. So in conclusion, we found out that cosine theta equals to 4/5. Cosine theta equals to 4/5. In the next step, we will implement the law of cosines in our triangle ABC. So I will repeat shortly on the law of cosines. I've already mentioned it in the past, so I'm going to do it quickly. The law of cosines is true in any triangle. So actually, if we have triangle ABC that could be any triangle, this is triangle ABC. The angle between side AB and side AC is theta. The length of side AB is equal to A units, or side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. Then we get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So in any triangle, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. We will implement the law of cosines in our triangle ABC. So according to the law of cosines, we will get that in our triangle ABC, cosine theta equals to 5 squared, that is 25, plus 6 squared, that is 36, minus AC squared over 2 times 5 times 6. Okay, so cosine theta equals to 25 plus 36 minus AC squared over 2 times 5 times 6. So cosine theta equals to 25 plus 36 is 61 minus AC squared over 5 times 6 is 30, and 30 times 2 is 60. We have already found out that cosine theta equals to 4 over 5. Cosine theta equals to 4 over 5, so we substitute cosine theta by 4/5, and it is equal to 61 minus AC squared over 60. We multiply this equation by 60, and we get that times 4 over 5 equals to 61 minus AC squared. Here 60 over 5 is 12, and 12 times 4 is 48. So in conclusion, we found out that 48 equals to 61 minus AC squared. Here we subtract from this equation 48 and 8 AC squared simultaneously, and we'll get that AC squared equals to 61 minus 48 is 13. Here we take a root out of this equation, and we get that AC equals to the square root of 13 units. So here we found out actually that AC equals to square root of 13 units. And actually, we have a formula for the area, for the radius of a triangle that blocks, for the radius of a triangle that blocks, for the radius of a circle that blocks triangle. According to the new formula, the radius of a circle that blocks triangle, it is equal to the multiplication of the sides of the triangle. That is, in this case, it is AB times BC times AC. AB times BC times AC over 4 times the area of the triangle that is blocked by the circle. In this case, it is triangle ABC. So the radius of this circle that blocks triangle ABC equals to the multiplication of the sides of the triangle over 4 times the area of this triangle that is inscribed by the circle. So here, according to this formula, we get that the radius of the circle that blocks triangle ABC equals to AB is 5 times BC is 6 times AC is equal to 13 over 4 times the area of triangle ABC equals to 9 units according to what is given as the question. So in conclusion, I found out that the radius of the circle that blocks triangle ABC will be equal to 5 times 6 is 30 times square root of 13 over 36. Here we will divide both the numerator and the denominator of this side of the equation by 6. Okay, and we get that the radius of the circle that blocks triangle ABC will be equal to 30 over 6 is 5 times square root of 13 over 36 over 6 is 6. So in conclusion, we found out that the radius of the circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, and in terms of numbers it is equal to 3.00 units. Okay, so we finished with the third method. In the next step I will summarize the lecture. We'll start with the first question. In the drawing we have a big circle. Inside this big circle we have triangle ABC. Triangle ABC is inscribed by the big circle, and inside the triangle ABC we have a small circle that is inscribed by triangle ABC, and we want to find out the blue area. Okay, so here we define the center of the small circle as O. We define the point of tendency of tangent BC with this small circle as M. We define the point of tendency of tangent AC with the small circle as L. And we define the point of tendency of tangent AB with the small circle as S. Then we join points O and M together by a straight line. OM is the radius of this circle because of the fact that it starts from the center of the circle and ends at point M, that is the point of the circle itself. This is exactly the definition of a radius. So here we have the radius OM that we know that is equal to 4 units. It is drawn to the point of tendency, and whenever you have a radius that is drawn to the point of tendency, then according to rule number 1, tangent CB will be perpendicular to the radius MO. So if CB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we join points O and M together by a straight line. ON is the radius of the circle. For the same reason, it starts from the center of the circle and ends at point N, that is the point of the circle itself. So here we have the radius OL that is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius LO. So if AC is perpendicular to LO, it means that this angle equals to 90 degrees and this angle will be also equal to 90 degrees. And we have the rule that any peripheral angle that rests to the diameter of a circle equals to 90 degrees. AB is the diameter of the circle, and peripheral angle ACB rests on AB, that is the diameter of the circle. Therefore, peripheral angle ACB equals to 90 degrees. So this angle ACB also equals to 90 degrees. So actually we found out that in quadrilateral LOMC we have 1, 2, 3 right angles. Okay, in quadrilateral OLCM we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle LOM. In total, the sum of those 4 angles, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that the missing angle LOM, this angle equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So actually we found out that in quadrilateral LOMC we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral LOCM as a rectangle. Okay? Quadrilateral LOCM is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle LOCM, its opposite sides are equal to each other. That is to say, LO equals to CM. LO equals to CM. But we have already found out that LO equals to 4 units. This is the radius of the small circle. So we can write here that LO equals to 4 units. And from this equation, 4 equals to LO equals to CM. We will derive that CM is also equals to 4 units. Here, CM equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we'll get that OM equals to LC. OM equals to LC. But we already found out that OM equals to 4 units. So we can write here that OM equals to 4 units. And from this equation, 4 equals to OM equals to LC. We will derive that LC also equals to 4 units. Here, LC equals to 4 units. So actually, we found out that quadrilateral LOCM is not a rectangle but a square, because all of its sides are equal to each other, they are equal to 4 units. Okay, then we defined side AC of triangle ABC as A, we define side CB of triangle ABC as B, and we define side AB of triangle ABC as C. And from the drawing it is very easy to see that AL equals to AC minus LC. AL equals to AC minus LC. That is to say AL equals to AC, that is A, minus LC, that is 4. So in conclusion, AL equals to A minus 4. AL equals to A minus 4. Likewise, it is very easy to see, to find out the length of line segment MB. From the drawing, it is very easy to see that MB equals to CB minus CM. Okay, MB equals to CB minus CM. CB equals to B. CM equals to 4, so in conclusion I found out that MB equals to B minus 4. MB equals to B minus 4. Then I present it to you. So here MB equals to B minus 4 and AN equals to A minus 4. Then I presented to you rule number 2, according to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So we focus on the common external point, point A. From the common external point, point A, we have two tangents to this circle, tangent AL and tangent AS. And according to rule number 2, they must be equal to each other. So here at point A, AL must be equal to AS according to rule number 2. AN equals to AS. But we have already found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. And from this equation, A minus 4 equals to AN equals to AS, we will derive that AS is also equals to A minus 4. Here, AS equals to A minus 4. Then we focus on the common external point, point B. From the common external point, point B, we have two tangents to this circle, tangent BS and tangent BM. And according to rule number 2, they must be equal to each other. Here, BM equals to BS according to rule number 2. But we have already found out that Bm equals to B minus 4, so we can write here that Bm equals to B minus 4, and from this equation B minus 4 equals to Bm equals to Bs, we derive that Bs is also equals to B minus 4. Here Bs equals to B minus 4, and we also know that AB is the diameter of this, the big circle. The diameter is twice as long as the radius, and the radius of the big circle equals to 13 units. Therefore, the diameter that is twice as long must be equal to 2 times 13, that is 26 units. So here C equals to 26 units, that is the diameter of the circle, it is equal to 26 units. So AS equals to 2R, that is equal to 26 units. From one side, AB equals to 26 units, this is the diameter of the circle. But from the other side, AB equals to AS plus SB. Again, AB equals to AS plus SB. That is to say, AB equals to AS, that is A minus 4, plus SB, that is B minus 4. So, here, AB equals to AS plus SB. That is to say, AB equals to AS, that is A minus 4, plus SB, that is B minus 4. So AB, that is 26, equals to A minus 4 plus B minus 4. A minus 4 plus B minus 4 is A plus B. Minus 4 is minus 8. So in conclusion, we found out that 26 equals to A plus B minus 8. We added 8 to this equation, equation number 1, and we found out that 26 plus 4 is 34. 34 equals to A plus B. Then we squared this equation and we got that A plus B squared equals to 34 squared. We open the brackets on this side of equation number 1, we found out that A plus B squared equals to A squared plus B squared plus 2 times AB. It is equal to 34 squared. 34 squared is 1156. Then, because of the fact that angle ACB equals to 90 degrees, it means that triangle ABC is the right triangle, so we can implement the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, that is to say, AB squared equals to AC squared plus CB squared. So AB equals to 26, therefore AB squared is 26 squared, that is 676. And it is equal to AC squared. AC is A, so AC squared is A squared, plus CB squared. CB is B, so CB squared is B squared. So in conclusion, we found out that here 676 equals to A squared plus B squared. And because of the fact that A squared plus B squared equals to 676 according to equation number 2, it means that we can substitute a squared plus b squared in equation number 1 by 676. We did it and we got that according to equation number 1, a squared plus b squared is 676, plus 2ab is 1156. We subtracted 676 from this equation number 1, and we got that 2 times AB equals to 1156 minus 676 is 480. So 2 times AB equals to 480. We divided this equation number 1 by 2, and we got that AB equals to 480 over 2 is 240. So we found out that AB equals to 420. Therefore, AB over 2 will be equal to 240 over 2, that is 120. And what is the area of the blue shape? It is equal to the area of triangle ABC minus the area of the small circle. The area of triangle ABC equals to the base of the triangle, that is AC, times the height to the base, that is CB over 2. I'll repeat again, the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So the area of triangle ABC equals to the base of the triangle, that is AC, times the height to the base, that is CB over 2, minus the area of the small circle, that is pi r squared. AC equals to A, BC equals to B. Therefore, the area of the triangle ABC equals to A times B over 2. And we already found out that A times B over 2 is 120. So we can substitute AB over 2 by 120. We did it and we got that the area of triangle ABC is 120 minus the area of triangle, minus the area of the small circle, that is pi r squared. But r is equals to 4, so r squared is 16. So in conclusion, we found out that the area of the small circle equals to 16 pi. And the area of the blue shape equals to the area of triangle ABC, that is 120, minus the area of the small circle, that is 16 pi. So the area of the blue shape equals to either 120 minus 16 pi square units, so in terms of numbers it is equal to 69.73 units. We finished with the first question, then I presented to you the second question, and we actually solved the second question in 3 different methods. Here we have triangle ABC that is described by this circle. The radius of triangle, the area of triangle ABC equals to 9 units, side AB equals to 5 units, side BC equals to 6 units. And we want to find out the radius of this circle that blocks triangle ABC. Okay, so first of all, from point A we draw perpendicular on BC, so this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And we know that the area of triangle ABC equals to 9 square units. So the area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is AD over 2. So 9, that is the area of triangle ABC equals to BC, that is 6, times AD over 2. 6 over 2 is 3, so we found out that 9 equals to 3 AD. We divided the equation number 1 by 3 and found out that AD equals to 3 units. Okay, here AD equals to 3 units. Then we focus on triangle ABD. This right triangle ABD. We implemented the Pythagoras theorem on this triangle ABD. This right triangle ABD. According to the Pythagoras theorem, the square of the equations equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to AD square plus DB square. AD is 5, so AD square is 5 square, that is 25. And it is equal to AD square. AD is 3, so AD square is 9. Plus BD square. We subtracted 9 from this equation number 2, and found out that BD squared equals to 16. We took out of this equation number 2, and found out that BD equals to the square root of 16, that is 4. So here BD equals to 4 units. Then what is the length of CD? CD equals to BC minus BD. CD equals to BC minus BD. So DC equals to BC, that is 6, minus DB, that is 4. So in conclusion, DC equals to 6 minus 4, that is 2. So DC equals to 2 units. Then we implemented the Pythagoras theorem on this right triangle, triangle ADC, and found out that the hypotenuse equals to square root of 13 units. Then from point A, we define the center of the circle as O, so, and we join points A and O together by a straight line, and we extended the straight line AO until it touches the circle at point E. We join points E and B together by a straight line. Angle ABE equals to 90 degrees. Why? Because it rests on the diameter AE. Okay, I repeat again. Angle ABE equals to 90 degrees because it rests on the diameter AE. And we also know that those two angles, they must be equal to each other because they rest on the same chord called AB. So in triangle ABE, if this angle equals to theta, this angle equals to 90 degrees, this angle must be equal to 90 degrees minus theta. And then this triangle ADC, for the same reason, this angle equals to 90 degrees minus theta. Then we prove that those two right triangles are similar to each other. Those two angles are equal to 90 degrees, those two angles are both equal to theta, and those two angles are both equal to 90 degrees minus theta. Therefore, those two triangles are similar to each other according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will derive that AB over AD equals to AE over AC. AB is 5, AD is 3. AE is the diameter of the circle that is 2 times the radius, 2r, over AC that is square root of 13. We multiply this equation by square root of 13 and found out that 2r equals to 5 times square root of 13 over 3. We divided this equation number 3 by 2 and found out the radius of the circle equals to 5 times square root of 13 over 6. Or in terms of numbers, it is a little bit greater than 3 units. We finished with the first method. Then I presented to you the second method. In the second method, here we know that according to the first method, DC equals to 2 units, BD equals to 4 units, AD equals to 3 units according to the first method. We extended AD by a straight line until it touches the circle at point E. And here, according to rule number 1, rule number 1 says that AO times OB equals to CO times OD. So according to rule number 1, because of the fact that chord AE intersects with chord BC at point D, then we get that PD times DC equals to AD times DE. BD times DC equals to AD times DE. According to rule number 1, BD is 4, DC is 2, and it is equal to AD, that is 3 times DE. So 8 equals to 3 times DE, therefore DE equals to 8 over 3 units. Okay? Then, according to rule number 2, we have here, if chord AB intersects with chord CD at 90 degrees, then 4 times R squared equals to A squared plus B squared plus C squared plus D squared. So here we have chord AE that intersects with chord BC at 90 degrees, therefore we get that 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. BD equals to 4, so BD squared is 4 squared, that is 16. This equals to 2, so this is squared is 2 squared, that is 4. AD equals to 3, so AD squared is 3 squared, that is 9. Plus 8 over 3 squared is 64 over 9. So in conclusion, we found out that the radius of the circle equals to, according to this equation, it is equals to 5 over 6 times square root of 13 units. So a little bit, in terms of numbers, it is a little bit greater than 3 units. Then I presented to you how to find out the radius of the circle according to the third method. In the third method, we define angle ABC as theta, and we know that the area of any triangle, if this is triangle ABC, that could be any triangle, the area of this triangle equals to A times B times sinus theta over 2. According to this formula, we get that the area of triangle ABC equals to AB times BC times sinus theta over 2, that is to say 5 times 6 times sinus theta over 2. The area of triangle ABC equals to 5 times 6 times sinus theta over 2. But we know that the area of triangle ABC equals to 9 square units. So here 9 equals to 5 times 6, this is 30 over 2. 30 over 2 is 15. So according to equation number 1, we found out that 9 equals to 15 times sinus theta. We divided this equation number 1 by 3, and we found out that 15 over 3 is 5, so, and 9 over 3 is 3. So we found out that 5 times sinus theta equals to 3. We divided equation number 1 by 5, and we found out that sinus theta equals to 3/5. And here with the trigonometric identity, that cosine theta equals to the square root of 1 minus sinus squared theta. So here cosine theta equals to 1 minus sinus squared theta. If sinus theta equals to 3/5, it means that sinus squared theta will be equal to 3/5 squared, that is 3 squared, that is 9 over 5 squared, that is 25. So here cosine theta equals to the square root of 1 minus 9 over 25, we multiplied 1 by 25, and then we divided by 25 in order to find factor with this expression. We found out that cosine theta equals to 25 minus 9 over 25. 25 minus 9 is 16, so it is 16 over 25. The square root of 16 is 4, and the square root of 25 is 5. In conclusion, we found out that cosine theta equals to 4/5. Then I presented to you the law of cosines, and we implemented the law of cosines in our triangle ABC. According to the law of cosines, this is triangle ABC that could be any triangle. The angle between side AB and side AC is theta. The log of AB is A, the log of AC is B, and the log of BC is C. Then according to the law of cosines, we get that cosine theta equals to A square plus B square minus C square over 2 times A times B. We implemented the law of cosines in our triangle ABC. According to the law of cosines, we get that here that cosine theta equals to 5 square plus 6 square minus AC square over 2 times 5 times 6. Cosine theta equals to 5 squared, that is 25, plus 6 squared, that is 36, minus AC squared over 2 times 5 times 6. 25 plus 36 is 61, minus AC squared over 5 times 6 is 30, and 30 times 2 is 60. Cosine theta equals to 4/5, so we substitute cosine theta by 4/5. Then we multiply this equation by 60 and found out that 60 times 4 over 5 is 60 over 5 is 12, and 12 times 4 is 48. So in conclusion, we found out that 48 equals to 61 minus AC squared. We added AC squared to this equation and subtracted 48, and we found out that AC squared equals to 13. We took a root out of this equation. and found out that AC, the missing side, AC equals to root of 13 units. Then we use this formula that the radius of any circle that blocks triangle equals to the multiplication of the sides of the triangle that is blocked by the circle over 4 times the area of the circle that is blocked by over 4 times the area of the triangle that is blocked by the circle. So here the radius of this circle that blocks triangle ABC will be equal to the multiplication of the sides of triangle ABC. That is to say, it will be equal to AB times BC times AC. AB times BC times AC over 4 times the area of this triangle, triangle ABC. Over 4 times the area of this triangle, triangle ABC. AB equals to 5, BC equals to 6, and AC equals to square root of 15. Over 4 times the area of triangle ABC, the area of triangle ABC is 9. So in conclusion, we found out that I equals to 5 times 6 is 30, times square root of 13, over 4 times 9 is 36. So I equals to 36 over 30 over 36 times square root of 13. We divided both the numerator and the denominator of this side of the equation by 6, and we got that the radius of this circle equals to 30 over 6 is 5, and 36 over 6 is 6. So the radius of this circle equals to either 5 over 6 times square root of 13 units, so in terms of numbers it is a little bit greater than 3 units. Okay, thank you very much.